Hi out there. Well, today we are going to go to the moon. Are you ready? Are you ready to go to the moon? I think I am. It's really kind of an exciting place here, right behind me. I put a great big picture of the moon so we can take a look at it. Well, let's see. If we were going to go to the moon today, how would we get away from the Earth? Let's take a look at my big old Earth here. The Earth, of course, has gravity. How would we get away from Earth's gravity to get to the moon? Hmm. Let's talk about gravity for a minute. Um, if you want to, you can stand up and just kind of illustrate gravity right where you are. So if you stand up, see if you can jump as high as you can. Now, right here in my den, if I jump really high, I might be able to get up a foot because I'm kind of an old lady and I'm kind of big, but I could probably jump a little bit here. But I can't escape Earth's gravity. Earth always pulls me back down. And I have a little block here. And if I tried to jump, there you go. That was a good jump. Yeah, how high do you think you could jump? It's pretty fun to try. You jump up and you reach as high as you can, and then boom, Earth pulls you back down. Always gravity pulls you towards the center of our big Earth. So how are we going to escape Earth's gravity? What force do we need? When we jump, when we use the power of our muscles in our legs and we push against the Earth's surface and we jump really high, that's the force we're using. The force in our bodies, our energy from our bodies. We're using that to push against gravity and go up as high as we can. But what other forces can we use to push against the gravity to get up away from Earth's gravity and get out there in space and then let kind of the moon's gravity help us take there? Well, if you have a balloon today with you, we're going to try a balloon experiment to kind of fool around with another force that could push against Earth's gravity. So, oh, my balloon has a hole in it. I better not use that one. Okay, so here we go. If you have a balloon, you can blow it up. That's the hard part. And pinch off the end. And we're going to use this as kind of a balloon rocket today. See, there is the air, where the air is going to come out. And when the air comes out, hopefully the balloon will go up. Now, I know from before that balloons are a little bit unpredictable because they go doo-doo-doo-doo-doo. But it's the air, the force of the air pushing against something that helps it go up or out or wherever it's going to go. So, okay, I'm going to put one more breath of air in my balloon, and hopefully you can do that too. And let's see. I'm going to let it go. 5, 4, 3, 2, 1. It did. It went up that time. It really, really went up high. It went up to the ceiling and it went over to the side of my wall. But the force of the air coming out the end pushed against the gravity and sent it flying. Okay, so here's another thing that you can do too. If you have a spoon hanging around, and I have a cotton ball, but you can have a little piece of paper or a hair tie or even a block, but I'm going to use a cotton ball because it's lighter. You can use the force, some potential energy, by pulling down on the spoon and then releasing it. Whoa! And my cotton ball went flying. So you're using forces to push against gravity. 1, 2, 3, bam! Oh, that cotton ball went far. I'm going to have to find it later. So, yeah. But how do you think, you can push down the space bar and answer this question too. How do you think that you would get all the way to the moon? What do you think you would take? Rocket ship. Rocket ship. Yep, exactly. That would be, just like we were holding the end of the balloon, the force of the fuel from the rocket would push against the gravity and send it way, way up. So yeah, a rocket ship right now is the best way we have of escaping Earth's gravity and getting to the moon. All right, so let's talk about some other things. Once we got to the moon, what would it be like when we got there? I have I have some blocks right here, and what kinds of things would we need to take with us because of what the moon has, and maybe what we have here on Earth that we're going to need if we went to the moon. So I'm going to stick my Earth right here so we can see it. And I have some blocks, and we're going to do some yes or no questions together. I have some yes blocks; those are the blue ones, and I have some no blocks, and those are the orange ones. And we're going to see, and we're going to stack them up to see what the moon has and maybe what the Earth has. Okay, so here's some of my yes or no questions. Does the moon have any air? You can
No.
No, so we're going to give the moon a no block. Can you see my no block? Uh-oh. Does the moon have a surface to stand on, to live on? Yes or no?
Yes.
Yes, it does. When we were talking about some of the other planets and places to go in the solar system, like Jupiter and Saturn, those have sort of a gas surface, dense gases all combined together. And you couldn't stand on those, but the moon, yes, the moon has a dirt surface to stand on. So yes for surface to stand on, but no for air. Okay, does the moon have any water? Yes or no? What do you think?
Yes.
Okay, you know what? The moon does have some water, but there's two yes blocks. It has a place to stand on and it has some water. But is the water easy to find? Yes or no?
No.
Oh, there you go. It's not easy to find. It might be in some of the craters, maybe at the poles, and it would be probably in the form of ice. So we're going to say the water is not easy to get to. So we have two yeses and two nos. Let's see. No air, some water, but how do you get to it? Does the moon have anything up there that we could eat? Yes or no?
No.
No. Oh no, another no block. Whoa. The no blocks are getting a little bit bigger than the yes blocks. How about that? Let's see. Oh, if you got to the moon, would you have any place like a house for shelter? Yes or no? Some place to live for shelter.
No.
No. Uh-oh. So there's another no block right there. No for air. Yes for some place to stand on. Yes for water, but no, because it's hard to get to for the water. And nothing to have for shelter. So there you go. So there are some hard things about living on the moon. So if we sent some astronauts or some people to live there, it would be, we'd have to take some things with us or figure out ways to use things that are already on the moon to help us live there. So that's what we're going to talk about next. I'm going to knock my yes and no tower blocks over. That's always fun. I love to play with blocks and knock them over. All right, I had a whole bunch here today. Can you think of something? Oh, before I put those blocks away completely, can you think of something that you would like to have on the moon that you have here on Earth, that if you went to the moon and were staying for a long time, can you think of something that you would like to take with you that the moon might have or might not have?
You would like a house on the moon.
A house on the moon? Yeah. That would be cool. That would, and it doesn't have it right now. Do you think, I always like to swim. And I'm thinking if I went there for a long time, I would like a swimming pool on the moon. Does the moon have any swimming pools right now? No, it doesn't. And I can think of some other crazy things that the moon doesn't have. Does the moon have any pizza?
No.
No, no, not right now, at least. They'd have to send back out to Earth to get pizza if we wanted to take some to the moon. We'd either have to take a lot of things to the moon or find out ways to use the things that are already there on the moon if we're going to make long trips and stay there. So, yeah, okay. So let's take a look at some of the things that the moon has that we might be able to use if we're going to stay there for a long time. Well, one of the things that I forgot to ask when we were stacking the blocks was the moon has lots and lots of sunlight. When we see a big full moon in the sky, we can see that the sun just shines and shines and shines right all over the whole face of the earth. And we can use that sunlight to create, power and energy and stuff. It's a big source of energy. The thing about living on the moon is, remember how we said it didn't have any air? It has no atmosphere, so some of the rays that hit the sun or the moon are kind of damaging. They are it's too much sunlight. It could hurt your skin. It's too much radiation. It could make people sick. So we're lucky with Earth. We have atmosphere, and some of those harmful sun rays just bounce right back off. But moon is not like that. So we'd have to protect ourselves. And that's why astronauts wear spacesuits. All right. So let's take a look at, if you have a magnifying lens right now, take a look and play with it for a little minute. We don't have any sunshine coming in our windows today, but my light up here is shining. And let's see if we can take a look at how, whoops, oh dear, I'm in the wrong spot. I'm going to change my camera again to the surface of the table. And I'm going to see if I can concentrate that sunlight with my lens here. And you can see how concentrated sunlight, we can do that too. We can make a beam of light, and that was reflecting off my plate. But let's see, there's my magnifying lens. Can you see the bright spot on my table? Yep. We are concentrating sunlight. So the moon definitely has a lot of sunlight, and we can, look at that. I can make the beam be concentrated. And we don't have a whole lot of sun today outside, but that is really hot. And we can, not right now because it's just from my light in my room, but if that was the sunshine, the sun in the sky outside, and when we were concentrating it at a certain point, we could actually feel the heat of the sun's rays. Now, sometimes the moon is really, really hot. Sometimes, when the sun shines on it, then it's surface. But then at night, when the sun doesn't hit the surface of the moon, it's really, really, really cold and frozen. Okay, so let's talk a little bit. We just talked about sunlight. Let's talk a little bit about water. Water to drink on the moon. What are we going to do? If we had just a bottle of water like this, if we had this filled up with water and we were going to try to take that to the moon, it would be very expensive. If you have a 2-liter bottle and you filled it up with water, it would weigh about, I don't know, a little over a pound or so, more than that actually. Water is pretty heavy. I read somewhere it would take $9,000 to send that much water up to the moon. That's a lot of money. And, I could drink this pretty quickly. And there's lots of other things. So it's really important that when astronauts get to the moon, that they might be able to use the water ice that's there and try to, I'm going to go back to my regular FaceTime camera and try to use that water, because it would be a lot easier to use the water ice than it would be to take take water from Earth and take it all the way up to the moon. So let's talk a little bit about water ice. I have a whole big bunch of ice cubes in my bowl here. So if you have some ice and some ice cubes, take out this ice cube and kind of feel it. Ah, wow. It's really hard. And it's starting to melt in my fingers. But if there's not a whole lot of heat on the moon where the water ice is, and it's probably in craters, and it's probably under, we made craters last week that had sand over the top of them, and so it's underground, really hard to get to. And water ice, oh, they'd have to mine it out of the ground. That's really difficult. So also in my big container here, I made some moon rocks. Doesn't that look cool? I took some purple food coloring and some baking soda, and I put them together and I put them in the freezer, so they're really, really, really hard. So I made myself some pretend moon rocks. And yes, we could probably take, and find some water ice up there and chop it up and then try to melt it, maybe with, some sun rays, but that's very hard to do. So I'm going to show you what maybe one way to get water. And back to the camera. So if we mined some moon rocks, see, these are all frozen. They were in my freezer. I even broke my spoon. There we go. Whoa, and you can do that. All you do is mix a little baking soda with some water, but see how hard they are? So let's see what we could do with some moon rocks, trying to get the water. I poured some water into the baking soda. That's what's holding it together. So there's water, and it's turned to a really hard chunk of ice. How could we get that out of there? I wonder. Well, we're going to let those sit there for just a minute. You can see how hard they are. But one thing we can do maybe with our bowl of ice is, have you ever taken a glass of water that's really, really cold? Whoops, I'm putting my ice inside a cup of water and let it sit there. And then the heat on the outside, the coldness on the outside, starts to condense. So we have two experiments going on right now. I put my water ice, because I forgot to do it a minute ago, put my water in a cup, and I'm letting my cup get really cold. And let's see if we can get any any condensation on the side of my glass. We'll let that sit there for a while and see. And meanwhile, back to my rocks. How are we going to get the water out of the rocks? I think we'd have to crush it up, but it's so hard that we'd really need something strong, a drill, something to scrape off those frozen water in the rocks. So it's really hard to get water up there. It really is. We'll come back to the ice cubes in the glass in a minute to see if we got any condensation. But lots of ways to get water, but very, very difficult. Okay. So one thing we can do by using the things on the moon is maybe some chemical reactions. So what I'm going to do is I'm going to see if maybe we can get some air to breathe. That's another thing. There's not a whole lot of oxygen on the moon. Maybe we can get some air to breathe on the moon by doing some chemical reactions with the moon rocks. Okay, I have some vinegar in my container right here, and I'm going to pour that over my baking soda frozen moon rocks, and let's see if we can get some bubbles going on here. There, I just squirted. I just squirted some vinegar over the top of my baking soda frozen moon rocks, and they're turning all fizzy and bubbly. Oh my goodness. Chemical reactions. I wonder if we could trap some of those, some of the bubbles. I bet we could. So let's see what happens if we try to trap some of those bubbles, because if we trap some of the gases that are trapped inside the moon rocks, let's see if we can do that. So I'm going to go back to the FaceTime camera. And if you have a 2-liter bottle with me and a balloon again, you can do this with me. Okay, so here's my bottle. Here's my balloon. And what I'm going to do is take a little bit of baking soda and a spoon, and I'm going to put some baking soda inside my balloon. Whoa, that's the hardest part. That's the messiest part. Spooning a little bit of baking soda in my balloon, going down inside there. Whoa. And I did get some there, but I am making a mess. It's okay. All right, so I got quite a bit in there. I want a little bit more. Remember those bubbles in my fizzy moon rocks? Okay, so I've got a bunch of baking soda, probably about a teaspoon in there. So now what I'm going to do is, I had that vinegar for my bubbly rocks. I am going to pour some vinegar in the bottom of my bottle. A bunch of it. Then I'm going to try to keep the baking soda down here while I take the balloon end and stick it over the top of my bottle. So chemical reactions can help us separate out the water or the air or the oxygen from other things that are already there on the moon. So that's what this is kind of illustrating. This is an example. So now we saw from the moon rocks over here that they were bubbling when we poured vinegar on them. The gases were coming off with the chemical reaction in the vinegar. So now I'm going to put some. Oh, look. There we go. We're trapping the bubbles from the chemical reaction in the bottom of my 2-liter bottle, and it inflated the balloon. The gases rose, so we could collect air, probably from crushing up some moon rocks and doing some chemical reactions with them. Kind of almost as pretty good as our little vinegar and baking soda reaction. So that is pretty interesting. So there's lots of things we could do with just the things that are on the moon to help us. Whoa, there we go. To help us get some water and help us get some air. Okay. Oh, chemical reactions. And there's one more chemical reaction that I want to do right in front of us. If you had a 9-volt battery and a little bit of water in a cup, you stick the end of a 9-volt battery down inside just a little bit. Eventually, you're running an electric current through your water. And eventually, you'll start to see some little bubbles coming off your 9-volt battery. And that's going to be really hard for you to see here on screen. But eventually, yep, there's tiny, tiny bubbles coming off by running electricity. And you can make electricity, of course, from solar power and run it through and separate out the oxygen that's actually in the water. So you could separate oxygen and hydrogen in the water. And when you get hydrogen, that's rocket fuel, because you're going to actually need a way to get back home from the moon too in your rocket. Wow. So back to my experiment with condensation. Along the edge of my glass, it was all dry, but now I am getting some condensation. So we could use condensation to get some water there up on the moon. Lots of different ways that we already know how to do, chemical reactions and physical reactions, that help us make some things that we really need on the moon from the things that are already there. Okay, so shelter, that's the last thing we're going to do today, is try to think about what kind of shelter that we need when we're on the moon. And so today I have brought with me a whole bunch of sticks out of paper. I took and rolled up, and I hope you did this ahead of time. I took a piece of paper and I just rolled it. Let me get this out of the way. I just rolled it from one of the corners all the way to the end. And I rolled it up so it looks like a big giant straw made out of a piece of paper. And that's what I did. I just rolled it and 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 rolled it. And then I taped it. Then I taped it right there and trimmed it. And all mine are trimmed to about 11 inches long. So they're about the same length. So what the astronauts would have to do is make something really strong, maybe for a temporary shelter, while maybe they dug into the surface to make a really thicker shelter to protect them from the radiation from the sun. But they need something really strong to live in for a temporary shelter until they got a bigger one. So triangles are really strong. So we're going to build a shelter based on triangles. So this is what we're going to do. Ahead of time, I made a bunch of these. They're all the same size. And if you have either some tape or a stapler, we're going to put them together. So I made one triangle, but we are going to do 1, 2, 3, 4, 5, 6, I think, triangles here. We're going to put them together like so. So I am going to use, I already got one. Well, I'm going to build another triangle right here so you can see how I did it. I'm going to hold it together, put a little bit of a staple right in the end, or you can tape it. And, whoops, I'm having trouble holding that together right now. You know, maybe stapling is not the best way to do it. I've made this out of newspaper before and used, there we go, I finally got it. I use tape. That might be easier to do. So now I'm going to do another corner to try to complete my triangle. And there we go. Start to put these together. Look at that. I've got one right here. Whoops. And yep, I think tape might be the way to go for this. And one right there. How you doing? Can you see the triangle that I'm trying to put together here? Now I have 3. It doesn't take too long, but it is a little tricky. And then I'm going to connect right there at the edge. Now, whoops, there we go. Whoa. Okay, so I'm going to make a couple more triangles really quick. Triangles, yeah. This is sort of a shape that would hold up really, really well. And you could kind of make it out of smaller pieces of things when you're actually on the moon if you brought some of those with you. This is really hard to staple. It's not working. Here we go. All right, and another triangle that I have here. Okay. So there we go. Staple, staple. I'm going to add another triangle and another cross piece. And you know, if you decide that you want to experiment rather than putting triangles together with all of these straws that you make, you can actually build your own sculpture that you think the astronauts might like to live on. So I'm going to put another cross piece here. Whoa! And across and across. This is getting really big. Do you think it's going to be really strong? Whoa, look at that. Oh boy. Uh-oh. It would be strong if I actually stapled it together better. Okay. Okay, so now I need another triangle. 1, 2, 3, 4, 5. 1, 2, 3, 4. And down here. This is a lot of staples and a lot of taping. 4. I'm going to do 2 triangles right now and then put them together. Staple, staple at the end. There. Now I have 5 and I'm going to put them all together. And then we're going to do something really cool to put a roof on it. Yeah, and when we get the structure, this is kind of like the skeleton, they call it. This is a partial geodesic dome. It's not the whole thing. Down here. Whoa, cool. Oops. My fingers and my stapler are working. Okay. Oh, I just need one right here. See how it's fitting together? Triangles and triangles and triangles and triangles. Oops. That's the hardest part. Is this ever going to come together with something strong? Right now it doesn't look like it, but it will. It will, it will, it will, it will. And one of the things we could think about if we were building a structure for the moon is how do we keep our oxygen inside so we don't lose it out onto the surface of the moon or Mars? Whoa. There, this is the last one. Now I call this a kind of a big triangle fence. And it's going to come around together. Oh, I think I've got it upside down. Okay, there we go. It's going to come around together. And it's going to bend. Whoa. I just broke it. But I'm going to need just a roof. How are we going to make this really, 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 really strong? So I'm going to take 5. I'm going to put this aside for a second. I got a big triangle fence here. And I'm going to take 5 of these straws together. 1, 2, 3. Actually, tape those together. There's 3. And it's going to look like a star. Now I've got a star There we go. I can see yours is starting to come together. So now on every point of my big triangle fence, I am going to pull this together and put a roof on it. There we go. Some of my staples have started to come apart, but see how I've got kind of a star? At every point, I'm going to staple or tape right there. And oh, is this ever going to be strong? Right now, I think I'm going to resort to some tape because my staples have started to pull apart a little bit. So here we go. I'm going to tape the roof on, and I can see how yours is starting to come together. It's very good. So I'm going to tape this on at every corner of my triangles. This is a lot of work, right? There we go. This is a lot of work. There we go. One more corner. Starting to come together. And so the point of all of this is that the astronauts could put something together that's really strong fairly quickly and live up there and have a place to be protected from maybe, say, asteroids that are hitting the surface of the Earth or the surface of the moon, or get out of the strong rays of the sun and be protected from the solar radiation. So fairly quickly, there we go. See, it's coming together. Now I'm going to have to already make repairs on my stupid staples, but there we go. A structure, someplace, some house that they could live. They were up there on the moon. See, that's where I have to fix it right there. I'm going to do that right now. And then hope we've given you a whole bunch of fun ideas to think about when you're thinking about taking a trip to the moon and what you're going to need when you get there. There we have our moon structure.
It looks super amazing.
Well,
Look at
thanks.
that.
Yeah, good. So you just do triangles and triangles and triangles and then put it on the top with the star. And tape probably works better than staples. I just learned that. Staples are really hard. So have fun building the rest of your moon shelter. And thanks for joining us on First Step Science. Something I had never ever seen before. And here's where you get to make a choice. Was it a giant Tyrannosaurus Rex? And I'm just gonna stick some pine cones in my box, and then the fun starts. I just start rolling them around. Air rushing out of the balloon is going to push that balloon up. So let's see what happens. All right, 1, 2, 3. Oh, wow. So that's how rockets kind of work. We are going to build 2 different kinds of rockets today.
Cork on his